Welcome to the last video of the third section of the academic chemistry class. This one's on chemical reactions or chemical change. In order to discuss chemical change, we need to review physical change. A physical change is when you alter something without altering what the substance is. You don't change the substance composition. Or, to put it more succinctly, the chemical you start with is the chemical you finish with. For example, you can have liquid water. If you heat it up, you get steam. But liquid water has the formula of H2O. Steam has the formula of H2O. You start with water molecules, and you end with water molecules. What you start with is the same chemical that you finish with. That's a physical change. A chemical property is the ability of an element or a compound to undergo or not undergo a specific chemical reaction. This is actually a very precise definition. A chemical property is the ability to do something. For example, iron can be oxidized to rust. Helium cannot combust. Glucose can react with oxygen to make carbon dioxide and water. A chemical change is when you actually undergo the reaction. In a chemical reaction, the chemical you start with are not the chemicals you end up with. For example, sodium chloride, table salt, can be decomposed to make sodium metal and chlorine gas. Hydrochloric acid can react with sodium hydrogen carbonate, and it makes sodium chloride and water and carbon dioxide. Calcium hydroxide plus potassium phosphate, when they are allowed to react, will make calcium phosphate and potassium hydroxide. Notice the chemicals you start with are not the chemicals you end up with. So let's take this last equation, and we're going to use this to illustrate a little bit of vocabulary. In a chemical reaction, which is denoted by the arrow, the chemicals to the left of the arrow are called the reactants or the reagents. Those are the chemicals that will react. To the right of the arrow, you have the product or products, those chemicals which are produced. So the reactants react to form the product. In a chemical reaction, the reactants and products must be different compounds. That is the definition of a chemical reaction. How do you know when a chemical change has occurred? Well, there are hints, but these hints are not absolute. The four major hints are: there is a transfer of energy. You can see this if you have a gas cooking top. On a gas cooking top, the propane combusts to form carbon dioxide and water, and also produces heat to cook your food. But a transfer of heat is not always an indication of a reaction, because if you have an electric stove, the coils heat up, but they don't change, but obviously there's an energy transfer. The second hint is a change in color. If substances change in color, there is usually a chemical reaction, but not always. If you've ever seen a mood ring, mood rings change color based upon your skin temperature, but they are not a result of a chemical reaction. Production of a gas. You have seen this most likely in elementary school when you combined vinegar and baking soda and it fizzed, the proverbial volcano. The production of the gas, which is carbon dioxide, hints very strongly the reaction has taken place. But production of a gas doesn't always mean that a reaction is taking place. Think about boiling water, where you are forming bubbles. You are forming a gas. That's a physical change, not a chemical change. And lastly is production of a solid. Usually when you mix two liquids together, that solid is called a precipitate. But the sheer making of a solid doesn't mean that a reaction has occurred. Think about taking water and turning it into ice. There is only one sure way to be 100% certain that a chemical reaction has taken place. You must test the composition of the reactants and the products, and if they have different physical properties, you have different compounds, and therefore a reaction has taken place. This brings us to a major fact of life. This is going to be something that you need to carry through the rest of the chemistry class. This is the law of conservation of matter. In a chemical reaction, matter can be neither created nor destroyed. The mass of the products produced must equal the mass of the reactants used. The total number of atoms does not change. The type of atoms do not change. This is the law of conservation of matter. So I reiterate it because this is vitally important. In a chemical reaction, matter can neither be created nor destroyed. Here is an example. Ammonium nitrate can explode and form nitrogen, oxygen, and water. The reaction would be written like this. Oh, and parenthetically, a chemical reaction is nothing more than a recipe. It tells you how to make something. Now let's suppose we had 40 grams of ammonium nitrate. We allow it to decompose, and you get 14.0 grams of nitrogen and 8.0 grams of oxygen. How much water was produced? For the reactant, the ammonium nitrate is 40 grams. The products, the nitrogen is 14 grams, the oxygen is 8 grams. We'll call the water mass X, and we know that the mass of the reactant has to equal the mass of the products. 40 grams equals 14.0 grams plus 8.0 grams plus X. Rearrange it, solve it, and you get 18 grams of water will be produced. The total mass of the reactant used must equal the total mass of the product produced. So to review this section, we covered what a chemical property is, the ability to undergo a chemical reaction, a chemical change, undergoing the chemical reaction, reactants, the chemicals you start with, to the left of the arrow, the products, the chemicals you end up with, to the right of the arrow, hints of reaction, but the hints are only hints, transfer of heat, color change, formation of bubbles, formation of a solid. Remember, the solid can be called the precipitate. But to be 100% sure that a reaction has occurred, you would need to test the products and the reactants to make sure that they are different. And most importantly, the law of conservation of matter, sometimes called the law of conservation of mass. In a chemical reaction, matter can be neither created nor destroyed. Well, that ends the third section. In the next section, we're going to deal with the wonders and the mysteries of the atom, furthering our journey into the joys of chemistry.